I had another example that I had prepped for class for us, but I didn't have time to get to it. It's very, very similar to the one I put up on a screencast before class, but I wanted to make sure you had more practice rather than less. So hopefully you've worked that problem before looking at the answers. Let me just take you through it step by step. So here's the thing. So full insurance, first dollar insurance, where I go to the doctor and get free coverage, and this is a big problem, especially in like a beverage model British system, although they use gatekeeping to limit the damage from moral hazard. But if I had a Blue Cross Blue Shield plan, my mother has Medicare and then a supplemental insurance plan, so she pays zero as far as the cost per doctor visit. That's first dollar coverage. It's very generous coverage. The problem we know from this framework is that it leads to overuse and thus social loss. And so we've moved to a system of co-pays and co-insurance. Used to be a lot of people had first dollar coverage. Now anymore, very, very few people have it. It's just too expensive, and employers aren't willing to cover it for very many of their employees. So we see a lot of co-pays that are intended and to some degree succeed in limiting this moral hazard problem. So here's an example of how that works. So let's suppose that an individual has a demand for a medical procedure that's given by the function Q equals 100 minus P. And when you graph that function, we could turn it into P equals 100 minus Q easily enough. And in this price quantity space, we have a y-intercept of 100 and an x-intercept of 100, and it has a slope of -1. That's a much flatter demand curve than people really have, but it's a really easy function to work with. That's why I pick such a function. It's not that there's zero math to it, but it's as easy a functional form as you'll ever see in these kinds of problems. All right, so the social cost is just a given in the problem. The social cost is 50, and we know that the optimal coverage is where every procedure that's valued by at least as much as its cost to provide, all these are valued at more than 50. They all get provided, but no procedure that is valued at 30 or 40 but costs 50 to provide is offered. So this is optimum. First dollar coverage has us down here at 100, and then if we had a $25 copay, I've got this blown up in the presentation for class, so if this is too small of this space, I apologize. We'd see usage drop from 100 to 75 with that copay. And then, what are we asked to do? What fraction of the social loss in the full insurance scenario is eliminated by a $25 copay? So, social loss under full, we're going to have to calculate that. And then social loss with $25 copay. And this is going to be easiest to solve graphically. Let me pick a different color, just pick a very light orange for my color. To find the social loss in the first dollar coverage case, that's where it costs 0 to get every procedure. So the person just keep having procedures as long as there's value greater than 0. So the problem with this outcome is that the cost per procedure are 50, and the value for every procedure after 50 is less than the cost. So if every extra procedure past 50 costs more than it provides value. So those resources would be better spent elsewhere in the economy. If we add up all that social loss due to that first dollar coverage and moral hazard, we get this area here. Well, what is that area? I better get it. Well, you guys have better eyes than I am. I have. So remember that the area of a triangle is 1/2 times base times height, and we have a triangle that's 50 units high, 50 units wide, and 1/2 times 50 times 50. That's 1/2 of 2,500. 5 times 5 is 25, and then we got 2 zeros to deal with. So that is 1,250, and the units are dollars per year, just in waste due to this first dollar coverage. Now, when we move to a system where there's a $25 copay, notice that usage falls by half. I'm going to pick a different blazing orange here. Anyway, in this case, when we've got a $25 copay, or this person has a $25 copay, they use 75 procedures a year. And notice that by the same logic, every procedure after 50 costs more than it was valued, and we get this smaller area of social loss, this darker orange triangle. And that's a triangle that's got a base of 25 and a height of 25. So 1/2 times 25 times 25 is equal to 312.50. 625 divided by 2. And when it turns out that 312.50 is exactly 1/4 of 1250. So we have social loss that's 1/4 the size that it was before, or another way to say that, the fraction of the social loss in the full insurance scenario that was eliminated by the $25 copay was 75%. So the answer is D. And there you have it. But the answer, getting the particular A, B, C, D answer isn't as important as being able to do the problem, set it up and do it. And that's the skill you want to be developing here.